Problem 59. We have a charged object plus Q of mass m equal 1 kilogram. Okay, we have here m equal 1 gram is suspended on a light string in the presence of a uniform electric field as shown in the figure. We have a uniform electric field E. When E equals to 3I plus 5J times 10 power 5 Newton per Coulomb, the ball is in equilibrium at theta equal 37 degree. As you see here, we have 37. First of all, you have to find the charge of the ball. We have to find Q. We have to find Q and the tension T of the light string. Okay. Here, first of all, I want to explain when you have a constant, in which case you have a constant field, uniform field. Only in one case, when you have a positive and negative plates, charged plates. This one has a plus Q and the other has minus Q. Between these two plates, we have a constant electric field, which is directed from the positive to the negative direction. Plates. So in this case, if we have the field in this direction, we understand well that in this case we have we have two plates. Let's say like this. We have a one plate here and one plate here. Okay, we don't need to only to understand in the case, in our case here, to have a field in this direction. Here we must have the positive charge, and here we have mass the negative charge, and between these two charges we have the field E. Just to understand this point. Okay, let's continue. Now we want to calculate Q and T. The solution of this problem is the same in order to calculate any parameter, you have to follow the same calculation. I mean, first of all, you have to draw the forces applied on the object. At the point P, you have the mass M. We have the weight equal to mg. And we have the tension of the cord. It's like this. And we have the electric force exerted on the object. It's in this direction. We have here Fe. Why? Because we said before, if we have here positive and negative plates. Here it's plus Q. Here we have minus Q. The field created is in this direction. Here we have E. If we put in the field a positive charge, we get a F in this direction because the charge is positive. So here we get E, we get F E. Q is positive, so E and F have same direction. So for this reason, we see here FE has the same direction as E. If Q is negative, so FE will have the opposite direction of E with and same direction and the opposite direction depends on the value of Q. Okay. In this case, we can put the components of each one. Here we have, we can put the x-axis and y-axis. Here we have y, and we will have x as components. For t, we have tx, and here we have ty. For fe, here we have fex, and here we have fey. So we can write fex and fey. And here we have t, we have tx and ty. You know, by corresponding, the angle theta here is equal to the angle theta here. We have two lines like this. This angle is equal to this angle by corresponding. Okay, now we have all the components. When you finish this point, you have to write the equation. Summation of F equal MA. We have the system is at equilibrium. When the system at equilibrium, so A equal to 0. So summation of F, which is equal to Tx plus Ty plus Fex plus Fey plus Mg. Mg has only y component. All these values, these vectors equal to 0. Don't forget, it's important to write this equation. Okay? Now we do the projection on x prime x. What we have on the x-axis, we have tx in the negative direction and fex in the positive direction. So we can write minus tx plus fex equal to 0. Okay? And we do the same for the y prime direction. In the positive direction, we have ty and we have fey. Okay, plus ty plus fey, and in the negative direction we have minus mg equal to 0. You know that tx, we take this triangle. Be careful, this triangle. And this one, tx is equal to here, is equal to tx. And this one is ty. And here we have t. So to calculate tx, we have to take the sine theta, the opposite side. So tx equal t sine theta plus fex. Fex here you have to know that we need to calculate this angle. Okay? To calculate fex, you know that f, we can say here f equal q times e. So fx equal q ex and fy equal q ey, because f and e also have the same direction. We can say here fex and fey. And by this equation here, you have ex and ey. Okay? So equal q, ex equal 3 times 10 power 5, and ey equal 5 times 10 power 5. We substitute each value here. So minus t sine theta plus fex equal 3 times 10 power 5 q equal to 0. The same for this one. Ty, if you look here in the triangle, ty is the adjacent side of theta. So we calculate by cosine theta. Ty equal t cosine theta plus fey equal 5 times 10 power 5 q equal to 0. Here, as you see, we have equation 1 and 2, two unknowns, two equations with two unknowns, t and q. Okay, we can substitute t, for example, here we have t equal 3 times, and you know that theta is equal to, we have the value of theta equal 37. Let's write the equation. We can see here t, we can put t to the other side, t equal 3 times 10 5 q divided by sine theta equal 37. Okay, this equation 1, we can say 1. And here we have t equal, we don't forget here mg. Okay, here we have mg. Here t plus 5 minus mg equal to 0. Okay, t equal we put this one here and mg here, equal mg minus 5 times 10 power 5 divided by cosine theta, equal m is equal to 1 gram. You have to put it in kilogram, equal 10 minus 3 kilogram. M times g equal to 10 minus 5 times 10 power 5 divided by cosine 37. Okay, here we calculated Q. Let me see. We have here T minus 10.5 Q. Okay, so this one is T and this one is T. T equal to T. We continue T equal to T. So we can say 3 times 10 5 Q divided by sine 37 equal to 10 power minus 2, this one, minus 2 minus 5 times 10 power 5 Q divided by cosine 37. You calculate Q, you get Q is equal to 10.9 times 10 minus 9 coulomb. This is the answer of Q. We substitute Q in the equation 1. So we can say here, equation 1, we have T equal 3 times 10 5 times Q, which is equal to 10.9 times 10 power minus 9 divided by sine 37. You will get the final answer equal 5.44 m Newton. Thank you.